And now in this lecture we will find out the length of chord AB. In the drawing we have a semicircle, and inside this semicircle we have two circles. Those two small circles are identical, and in the middle we have the middle circle. The middle circle is tangent to the semicircle at point O, and point O is the center of the semicircle, and point C is the center of the middle circle. We know that PQ, that is the diameter of the semicircle, it equals to 8 units, and the diameter of any circle is twice as large as the radius. So if the diameter equals to 8 units, then the radius equals to 4 units. So the radius of this semicircle equals to 4 units. That is to say, PO, that is actually the radius of this semicircle, equals to 4 units in its size, and OQ, that is also the radius of this semicircle, it equals to 4 units. And OX, it is also the radius of this semicircle, therefore it also equals to 4 units, but OX is not only the radius of the semicircle, but it is also the diameter of this middle circle. And if the diameter of this middle circle equals to 4 units, then the radius of this middle circle will be equal half of it. That is to say, it will be equal to 2 units. That is to say, CX, the radius of the middle circle, will be equal to 2 units. And OC, that is also the radius of the middle circle, will be equal to 2 units. And we also know that AB is parallel to PQ. We will define the center of this small circle as point M. Then we join together points M and C by a straight line. So actually MC is the distance between the radius of the center of the small circle, that is point M, and the center of the middle circle, that is point C. And the distance between the centers of two circles that have an external length between them, like in this drawing, the small circle is tangent to the middle circle at this point. We will define the touching point between the two circles as point Y. So whenever you have two circles with an external length between them, like in this drawing, then the distance between the centers of those two circles, in this case is MC, will be equal to the sum of the length of their radiuses. And if we define the radius of the small circle as R, that is to say MY will be equal to R, so the length MY, or the length of the radius, is R units, and the radius of the middle circle will be also CY, and we know that the radius of the middle circle equals to 2, that is to say CY equals to 2, so the distance between the centers of those two circles, it is actually R plus 2 units. Okay? Then we will define the touching point between the tangent PQ and the small circle, this point, is point N. Point N it is actually the point of tangency of tangent PQ with this small circle. We will join together points M and N by a straight line. So actually Mn is the radius of this small circle, that is to say it equals to R. And we have this radius, the radius Mn, it is drawn to the point of tangency, that is to say it is drawn to point N, that is the point of tangency of tangent PQ with this small circle. Therefore, the tangent PQ will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees, and this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay, likewise, we have the radius CO of the middle circle that is drawn to the point of tangency. The point of tangency is point O. Therefore, according to the rule that I mentioned, the tangent PQ will be perpendicular to this radius CO, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And then from point M we will draw perpendicular to CO, the radius of the middle circle. So this angle will be a right angle, and this angle will be also a right angle. So as you can see from the drawing, quadrilateral MNO, and we will define the touching point between the tangent from N to CO as point D. So quadrilateral MNOD has 3 right angles, 1, 2, 3. And we know that AB is parallel to PQ. AB is parallel to PQ. And we have the rule that says that corresponding angles between parallel lines are equal to each other. So those two angles, this angle and this angle, will be equal to each other because they are the corresponding angles that are located between the parallel lines AB and PQ, therefore they are equal to each other. But we know that this angle, it is a right angle, therefore, and those two corresponding angles are equal to each other. Therefore, this angle will be also a right angle, that is to say, it equals to 90 degrees. Okay? Likewise, because of the fact that AB is parallel to PQ, those two corresponding angles will be also equal to each other. So this angle that is the right angle will be equal to this angle, because there are two corresponding angles that are located between the parallel lines AB and PQ. Therefore, they are equal to each other. But we know that this angle is 90 degrees, so this angle will be also 90 degrees because those two angles are equal to each other. Okay? So I will draw the quadrilateral MNOD and the right triangle CDM. We will define this point as point E. So I draw again the quadrilateral MNOP. And the right triangle CY and the right triangle CDM. Actually, in quadrilateral MDON, we have three right angles, 1, 2, 3. And we have a rule number 1, that states that the sum of the angles in any quadrilateral equals to 360 degrees. According to rule number 3, the sum of the angles in any quadrilateral equals to 360 degrees. I'll read rule number 1 again. According to rule number 1, the sum of the angles in any quadrilateral equals to 360 degrees. And especially in quadrilateral MDON, in quadrilateral MDON, the sum of its angles must be equal to 360 degrees. And quadrilateral MDON has three right angles, that is to say 1, 2, 3. So the sum of the three right angles is 90 times 3 is 270 degrees. Plus the size of this angle, we define this angle as angle X. Plus angle X must be equal to 360 degrees according to rule number 1. I will repeat again, the sum of the angles in quadrilateral MDON must be equal to 360 degrees. That is to say, the sum of three angles, that is 270 degrees, plus the size of the fourth angle, that is X, must be equal to 360 degrees according to rule number 1, that the sum of the angles in any quadrilateral equals to 360 degrees. Here we will subtract 270 degrees from this equality, and we will get that angle X equals to 360 degrees minus 270 degrees. It is actually 90 degrees. So we found out that angle X is a right angle, equals to 90 degrees. Therefore, this is actually a right angle. So in quadrilateral MNOD, we have four right angles, and we have rule number 2 that states that any quadrilateral that has 4 right angles, it must be at least a rectangle. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So I'll read rule number 2 again. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So quadrilateral MDON must be at least a rectangle. And we have also rule number 3. Rule number 3 states that a rectangle, the opposite sides of a rectangle are equal to each other. I will read rule number 3 again. Rule number 3 states that the opposite sides of a rectangle are equal to each other. So here we know that Mn is the radius of the small circle. That is to say, so here also Mn equals to R. And we know that the opposite sides of a rectangle are equal to each other according to rule number 3. That is to say, side Mn equals to DO, Mn equals to DO, according to rule number 3. Mn equals to DO according to rule number 3 that the opposite sides of a rectangle are equal to each other. But we know that Mn equals to R, it is the radius of the small circle. Mn equals to R. So from this equality we will conclude that DO also equals to R. DO equals to R. So we can write here that DO also equals to R. And what is the value of CO? CO, as you can see from the drawing, CO, it is actually the radius of the middle circle, that is to say it equals to 2 units. So you can write here that CO, that is the radius of the middle circle, it equals to 2 units. Okay? CO equals to 2 units. That's the radius of the middle circle. So CO minus DO equals to CD. CO minus DO equals to CD. Okay, CO minus DO equals to CD. But we know that CO equals to 2 units and DO is the radius equals to R, the radius of the small circle. So in total we found out that CD equals to 2 minus R. So we can write here that CD this line segment equals to 2 minus R. And what is the value of MC? We have already found out that the value of MC, that is the distance between the centers of the small circle and the middle circle, it is actually equals to 2 plus R. So here MC, it is actually equals to 2 plus R. MC equals to 2 plus R and CD equals to 2 minus R. So we will focus on the right triangle CMD. On the right triangle CMD, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle CDM, it is actually MC. So the square of the hypotenuse is MC squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to CD squared plus MD squared. I will repeat again. In the right triangle CMD, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MC square equals to CD square plus MD square. But we have already found out that MC equals to 2 plus R, so MC square will be equal to 2 plus R squared. and it equals to CD square. CD equals to 2 minus R. Therefore, CD square will be equal to 2 minus R square plus MD square. I will repeat again. MC equals to 2 plus R, so MC square will be equal to 2 plus R square. CD equals to 2 minus R, therefore CD square will be equal to 2 minus R square. MD square is MD square. Here we will open the brackets on both sides of equation number 1 and we will get that 2 plus R square is 4 plus R square plus 4R, and it equals to 2 minus R square. 2 minus R square is 4 plus R square minus 4R plus MD square. So here we have R square on both sides of equation number 1, so R square will get cancelled, and we also have 4 on both sides of the equation number 1, so 4 will also get cancelled. So what is left after we cancel those two expressions? What is left here? What is left from equation number 1 is, in this side of equation number 1 is 4R. So I write it down. And on the other side of equation number 1, what is left? It is actually minus 4R plus MD square. Here we will add 4R to this equation number 1, and we will get that 4R plus 4R is 8R. 8R equals to MD square. So here we will take a root out of equation number 1, and we will get that MD equals to the square root of 8R. Okay, MD equals to the square root of 8R. So MD equals to the square root of 8R. We know that 8 is 4 times 2, so we'll substitute 8 by 4 times 2. So we get that MD equals to the square root of 4 times 2 times R. And we know that the square root of 4 is 2, so we write it down. We'll get that MD equals to 2 times square root of 2r. MD equals to 2 times square root of 2r. So we can write here that MD equals to 2 times square root of 2r. And we have rule number 3, that the opposite sides of a rectangle are equal to each other. That is to say, MD equals to NO. MD equals to NO according to rule number 3, that the opposite sides of a rectangle are equal to each other. I'll repeat again. MD equals to NO according to rule number 3, that the opposite sides of a rectangle are equal to each other. But we have already found out that MD equals to 2 times square root of 2r. So right here that MD equals to 2 times square root of 2r. So from this equality, we will conclude that NO also equals to 2 times square root of 2r. Okay, NO also equals to 2 times square root of 2r. So we can write here that NO equals to 2 times square root of 2r. In the next step, we will join together points M and O by a straight line. And we will calculate the value of MO from the original drawing. Here we will join together points M and O by a straight line. As you can see from the drawing, AM is the radius of this small circle, that is to say it equals to R. And what is the value of MO? You can see from the drawing that MO is actually AO minus AM. I write it down that MO MO equals to AO minus AM. I'll repeat again. MO equals to AO minus AM. So MO equals to AO. What is AO? As you can see from the drawing, AO is the radius of the semicircle, that is to say it equals to 4 units. So AO equals to 4 units, this is the radius of the semicircle, minus AM. We've already found out that AM is R, the radius of the small circle. So in total we found out that MO equals to 4 minus R. So we can write here that MO equals to 4 minus R. So here we will focus on the right triangle, triangle MNO, on the green right triangle, triangle MNO, and we will implement the Pythagoras theorem in the right green triangle, triangle MNO. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse in the green triangle is OM, so the square of the hypotenuse is OM squared. And it equals to the sum of the squares of the perpendiculars, that is to say it equals to MN squared plus NO squared. I'll repeat again, in the right triangle, triangle MNO, the right green triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, MO square equals to MN square plus NO square. We have already found out that MO equals to 4 minus R, therefore MO square will be equal to 4 minus R square. So OM or MO square equals to 4 minus R square. MN is R. So MN square will be equal to R square. Yes. MN square equals to R square. And NO equals to 2 times square root of 2R. So NO square will be equal to 2 times square root of 2R square. And NM is also an MN square equals to R square. NO is 2 times square root of 2R, so NO square equals to 2 times square root of 2R square. Here we will open the brackets of equation number 2, on both sides of equation number 2, and we will get that 4 minus R square is actually 16 plus R square minus 8R, and it equals to R square plus 2 times square root of 2R square, it is actually 8R, So here we have r square on both sides of equation number 2, so r square will get cancelled. After we cancelled r square, we will add 8r to this equation, equation number 2. And we will get that 16 equals to 8r minus 8r is 0, and here 8r plus 8r is 16r. So actually we got that 16 equals to 16r. Here we will divide equation number 2, this equation by 16, and we will get that r equals to 1. So we found out that the radius of the small circle equals to 1 unit. So we can write here that r equals to 1. R equals to 1. And here we know that CD equals to 2 minus R, and R equals to 1. So CD equals to 2 minus 1, that is 1. So CD also equals to 1. So in the next step, we will focus on the right triangle CEY. The green right triangle CEY. And we will also focus on the right triangle CDM. Those two angles are right angles and they are equal to each other, so angle CY in the green triangle CY equals to angle CDM in triangle CDM, and both angles are right angles, they are equal to 90 degrees. So we got that angle CY equals to angle CDM, and both angles are right angles, they are equal to 90 degrees. And we also have this angle, angle C is a common angle, it belongs to both triangles, it belongs to the great triangle, and angle C also belongs to the bigger triangle, triangle CDM. So we can write down that angle C equals to angle C is a common angle that belongs to both triangles. Okay, angle C equals to angle C is a common angle that belongs to both triangles. And those two angles are also equal to each other. according to third angle theorem. So we can write down that angle, this angle CYE or triangle CYE equals to angle CMD or triangle CDM, and they are equal to each other according to third angle theorem. So I repeat again, angle CY equals to angle CMD according to third angle theorem. Those two angles are equal to each other according to third angle theorem. So, what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. So, and here we have, those are the first pair of angles that congruent in those two triangles, and this is a common angle, so it equals to itself, and this is the second pair of angles that congruent. So if we have two pairs of angles that congruent according to third angle theorem, the third pair of angles must also congruent, that is to say those two angles are equal to each other. Okay, that is third angle theorem. So that is actually the third angles that congruent in those two right triangles. So we actually proved that all three angles 1, 2, 3 of triangle CYE congruent to all three angles 1, 2, 3 of triangle CDM. Therefore, we proved that those two triangles congruent to each other according to angle similarity rule. So I write it down. We actually proved that triangle CYE is similar, this is the sign of similar, to triangle CDM according to angle similarity rule. I will repeat again. We actually proved the triangle CYE congruent to triangle CDM according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle congruent to all three angles in another triangle, then you proved that those two triangles are similar to each other according to angle similarity rule. And from the fact that triangle CYE is similar to triangle CDM, we will conclude that the following equality is true. We will actually conclude that CE over CY in triangle CYE equals to MD over MC in triangle CMD. I will repeat again. CE over CY in the green triangle CYE is equal to CD over CM in triangle CDM. Okay? So CD or CE over CY. What is the value of CY? The value of CY, you can see from the original drawing that CY equals to 2 units. It is the radius of the middle circle. So CY equals to 2. That equals to MD. MD. What is the value of MD? It is actually MD. It is actually CD, not MD but CD. It is CD. This line segment is line segment CD. And what is the value of CD? We've already found out that CD equals to 1 unit. CD equals to 1 unit over MC. MC equals to 2 plus R, and R equals to 1, so 2 plus 1 is 3. So MC equals to 3. So in total we found out that CE over CY, CE is 2, and here CD is 1 unit and MC is 3 units. So in total we found out that according to equation number 3, CE over 2 equals to 1 over 3. We will multiply equation number 3 by 2 and we will get that CE equals to 2/3 units. CE equals to 2/3 units. So we can write here that CE equals to 2/3 and what is the value of ED? You can see from the drawing that ED equals to CD minus CE. So we can write here that ED equals to CD minus CE. Okay? So ED equals to CD is 1 and CE, we already found out that CE equals to 2/3. So it is 1 minus 2/3 is third. So we found out that ED equals to third. 1 over 3 or third. ED equals to third. Here ED equals to 1 over 3. And what is the value of OE? The value of OE, you can see from the drawing that OE equals to OD plus DE. OE equals to OD plus DE. OE equals to OD plus DE. So OE I repeat again. OE equals to OD plus DE. That is to say, OE equals to OD. OD is 1. And we already found out that DE equals to third. So OE equals to 1 plus third is 4 thirds. 4 over 3. I'll repeat again. OE equals to OD plus DE, and OD equals to 1 and DE equals to third. So in total OE equals to 1 plus third. 1 plus third is 4 over 3 units. So OE equals to 4 over 3 units. So we can write here that OE equals to 4 over 3 units. Okay. In the next step, we will connect together points O and B by a straight line. Actually, OB is the radius of the semicircle. OB is the radius of the semicircle, that is to say it equals to 4 units. And what is the size of angle OEB? The size of this angle OEB. The size of this angle, it is actually, we know according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if you look on this side of the straight line OX, the sum of its angles must be equal to 180 degrees. So if we focus on this point E, the sum of the angles at point E at this side of the straight line OX will be equal to 180 degrees. So at this point E, we have this angle that is a right angle plus the size of angle OEB must be equal to 180 degrees. So we have the formula that 90 degrees plus the size angle of angle OEB must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So the sum of the angles on this side of the straight line OX at point E must be equal to 180 degrees. That is to say 90 degrees plus angle OEB must be equal to 180 degrees. 90 degrees plus angle OEB must be equal to 180 degrees. We will subtract 90 degrees from this equation from this equality, and we will get that angle OEB equals to 180 degrees minus 90 degrees is 90 degrees. So angle OEB is a right angle, it equals to 90 degrees. Angle OEB is a right angle, it equals to 90 degrees. So here we have a right angle this angle is a right angle, it equals to 90 degrees. If this angle is a right angle, then triangle OEB is a right angle. So I will copy the right angle triangle OEB here in a new page, and we will calculate the value of EB, side EB of triangle OEB. So we have already found out that OE equals to 4 over 3 units, and OB is the radius of the semicircle, that is to say it equals to 4 units. And the only thing that is left to do is to find out the size of side EB of this right triangle, triangle OEB. So in the right triangle, triangle OEB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse in the right triangle OEB is OB, so the square of the hypotenuse is OB squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OE squared plus EB squared. I will repeat again. In the right triangle, triangle OEB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to OE square plus EB square. We know that OB equals to 4 units, therefore OB square is 4 square. 4 square is 16. So OB square equals to 16. OE equals to 4 over 3, so OE square equals to 4 over 3 square plus EB square. Here 4 over 3 square is 16 over 9, so I will write it down according to equation number 4. 16 equals to 16 over 9 plus EB square. Here we will subtract from this equation, equation number 4, 16 over 9, and we will get that 16 minus 16 over 9 equals to EB squared. Here we will multiply 16 by 9 and then we will divide it by 9 in order to have a common factor which is minus 16 over 9. So we will get that 16 times 9 over 9 minus 16 equals to EB squared. Sixteen times 9 minus 16 is 16 times 8, so I write it down. 16 times 8 over 9 equals to EB squared. So we got that 16 times 8 over 9 equals to EB squared. We know that 16 is 8 times 2, so we'll substitute 16 by 8 times 2. And we will get that according to equation number 4, so 16 is 2 times 8, times 8 over 9 equals to EB squared. Here we will take a root out of this equation number 4, and we will get that EB equals to the square root of 2 times 8 over 9. The square root of 8 times 8 is 8, and the square root of 9 is 3, so I write it down. We will get that EB in total equals to 8 over 3 times square root of 2 units. So we found out the value of EB. It equals to 8 over 3 times square root of 2 units. In the next step, we will prove that those two right triangles can go into each other. So the triangle OEB, the right green triangle, triangle OEB, is congruent to the right green triangle, triangle OEA. So I will copy those two right triangles in a new page, and we will prove that they are congruent to each other. Okay, so we have so we will prove that those two right triangles, triangle OEB, is congruent to triangle OEA. First of all, we know that OA equals to OB equals to 4 units. They are the radiuses of the semicircle. So OA equals to OB equals to 4 units. And we also know that OE equals to OE. OE is a common side, it belongs to both triangles. So OE equals to OE. It's a common side that belongs to both right triangles. So by proving that those two sides congruent in both triangles, we actually proved that those two triangles congruent to each other according to rule number 4. So what is rule number 4? Rule number 4 states that if the hypotenuse and the perpendicular in one right triangle congruent to the hypotenuse and the perpendicular in another right triangle, then the right triangles congruent to each other. I will read rule number 4 again. According to rule number 4, if the hypotenuse and the perpendicular in one triangle congruent to the hypotenuse and the perpendicular in another triangle, in another right triangle, then the right triangles congruent to each other. And we actually proved that the hypotenuse OB and the perpendicular OE in the right triangle OEB congruent to the hypotenuse OA and the perpendicular OE in the right triangle OEA. Therefore, we actually proved that those two right triangles congruent to each other. Therefore, according to rule number 4, triangle OEA is congruent, this is the sign of congruent, to triangle OEB. According to rule number 4, for the fact that those two triangles congruent to each other, we will conclude that AE equals to EB. AE equals to EB. Side AE equals to side EB. AE equals to EB. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides AE and EB will be equal to each other. That is to say, AE equals to EB. And what is the value of AB? From the drawing, you can see that AB is actually equals to AE plus EB. Okay, from the drawing you can see that AB equals to AE plus EB, but we have already proved that AE equals to EB, so we can substitute AE in this equality by EB. So we do it and we get that AB equals to EB plus EB. That is to say, AB equals to 2 times EB. So AB equals to 2 times, we have already found out that EB equals to 8 over 3 times square root of 2 units. So in total we will get that AB equals to 2 times 8 is 16 over 3 times square root of 2 units. AB equals to 16 over 3 times square root of 2 units. Or in terms of numbers, it equals to 7.54 units. I will repeat again. AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. We'll see it on the drawing itself also. We found out that AB equals to either 16/3 times square root of 2 units, or in terms of numbers, chord AB equals to 7.54 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the length of chord AB. We know that we have here a semicircle, and inside this semicircle we have 3 circles. Those 2 small circles are identical, and the center of the semicircle is at point O, and the center of the middle circle is at point C. We know that PQ, that is the diameter of the semicircle, is equals to 8 units, and the diameter of any circle is twice as large as the radius. Therefore, if the diameter of the semicircle equals to 4 units, then the radius of this semicircle will be equal to 4 units. That is to say, PO equals to 4 units, and OQ, that is the radius of the semicircle, will be also equal to 4 units. And OX, that is also the radius of the semicircle, will be also equal to 4 units. But OX is not only the radius of the semicircle, but it is also the diameter of the middle circle. So we know that the diameter of the middle circle OX equals to 4 units. And if the diameter of the semicircle if the diameter of the middle circle equals to 4 units, then the radius of this middle circle will be half of it, will be equal to half of it, so it will be equal to 2 units. So CX, that is the radius of the middle circle, will be equal to 2 units, and OC, that is also the radius of the middle circle, will be also equal to 2 units. And CY, likewise CY, will be also equal to 2 units because it is the radius of the middle circle. Okay? Then we define the center of this small circle as point M. We join point M and C together by a straight line. MC is the distance between the centers of the small circle and the middle circle, and the distance between 2 circles that have an external length between them, it is actually the length, the sum of the lengths of their radiuses. It is to say it equals to R plus 2. So MC equals to R plus 2. Then we join together points M and N by a straight line. MN is the radius of this small circle, and N is the point of tangency of tangent PQ with this small circle. And we have this radius MN, it is drawn to the point of tangency, that is to say it is drawn to point N, that is the point of tangency. Therefore, the tangent PQ will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, the radius CO of the middle circle is drawn to the point of tangency, that is to say it is drawn to point O, that is the point of tangency of tangent PQ with this middle circle. Therefore, the radius PQ, therefore the tangent PQ will be perpendicular to this radius OC. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Then we drew perpendicular from point M to CO. So this angle is 90 degrees and this angle it is also 90 degrees because this is perpendicular to CO. Then we actually know that AB is parallel to PQ. Therefore, those two corresponding angles that are located between the parallel lines AB and PQ will be equal to each other, and this angle is 90 degrees, so this angle AEC will be also equal to 90 degrees. Likewise, on the other side, we have those two corresponding angles. They are equal to each other because they are located between the parallel lines AB and PQ. But we know that this angle is 90 degrees, so this angle will be also equal to 90 degrees. That is to say, angle XEB will be equal to 90 degrees. Then actually draw the quadrilateral MNOD and the right triangle MCD. Okay, and as you can see here, MN is the radius of the small circle. MN equals to R. And we have rule number 1. That states that the sum of the angles, according to rule number 1, the sum of the angles in any quadrilateral equals to 360 degrees. So if we focus on the quadrilateral MNDO, this quadrilateral, the sum of its angles equals to 360 degrees. This is to say, the sum, those three angles, the right angles, so the sum of those three right angles is 270 degrees, plus the size of this angle that is defined as x must be equal to 360 degrees according to rule number 1. In quadrilateral MDON, the sum of its angles must be equal to 360 degrees according to rule number 1, that is to say 270 degrees plus x plus angle x must be equal to 360 degrees. We subtracted 270 degrees from this equality and we got that angle x equals to 360 degrees minus 270 degrees, that is to say it equals to 90 degrees. So we found out that this angle is the right angle, it equals to 90 degrees. Okay, so actually quadrilateral MNDO has 4 right angles. And according to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So this quadrilateral MDON that has 4 right angles, it must be at least a rectangle, if not a square. And we have rule number 3 also, that the opposite sides of a rectangle are equal to each other. That is to say, side MN of rectangle MNDO equals to side DO, MN equals to DO. According to rule number 3, MN equals to DO, but we know that MN equals to R, MN equals to R. So from this equality we will derive that DO also equals to R. DO also equals to R. And what is the size of line segment CO? The size of line segment CO, you can see from here that CO is the radius of the middle circle, that is to say it equals to 2 units. CO equals to 2 units. And DO equals to 1. So CO minus DO equals to CD. CO minus DO equals to CD. DO equals to 1 and CO equals to 2 units. So in total, CD equals to DO to CO, that is 2 units, and minus DO, that is R. So in total we found out that CD equals to 2 minus R, CD equals to 2 minus R, then we focused on the right triangle, triangle CMD. Here, what is the value of MC? We have already found out that MC equals to 2 plus R. MC equals to 2 plus R, and CD equals to 2 minus R. So we focused on the right triangle, triangle CMD. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars. That is to say, MC square equals to CD square plus MD square. MC, we have already found out that MC equals to 2 plus 1, so MC square will be equal to 2 plus 1 square. CD, we have already found out that CD equals to 2 minus R. Here, CD equals to 2 minus R. So CD square will be equal to 2 minus R square plus MD square. We open the brackets in equation number 1, and we got that 2 plus R square equals to 4 plus R square plus 4R, and 2 minus R square equals to 4 plus R square minus 4R plus MD square. Here we have 4 on both sides of the equation, number 1, so 4 will get cancelled, and we have R square on both sides of equation number 1, so R square will also get cancelled. So what is left from equation number 1 after we cancel those two expressions? What is left actually in this side of equation number 1, what is left is 4R, and what is left in the other side of equation number 1, what is left, it is actually minus 4R plus MD square. Here we added 4R to this equation number 1, and we got that 4R plus 4R equals to 8R, and 4R minus 4R is 0, so in total we got that 8R equals to MD square. Here we took a root out of equation number 1, and we got that MD equals to the square root of 8R. But we know that 8 is 4 times 2, so we substituted 8 by 4 times 2, and we got that 8 equals to the square root of 4 times 2R. The square root of 4 is 2, so we found out that MD equals to 2 times square root of 2R. So we can write here that MD equals to 2 times square root of 2R. And we have rule number 3 that states that the opposite sides of a rectangle are equal to each other. That is to say, MD equals to NO. MD equals to NO, but we have already found out that MD equals to 2 times square root of 2R. So from this equality we will conclude that NO also equals to 2 times square root of 2R. So we wrote here that NO equals to 2 times square root of 2R. Then we actually connected together points M and O by a straight line, and we found out the value of MO. What is the value of MO? Here we connected together points M and O by a straight line, and we also connected together points M and A by a straight line. As you can see from the drawing, AM is the radius of the small circle, that is to say it equals to R, and MO equals actually to AO minus AM. That is to say MO equals to AO minus AM. And AO, what is AO? AO is the radius of the semicircle, that is to say it equals to 4 units, and AM equals to R, it is the radius of the small circle. So in total we got that MO equals to AO, that is 4 units, and MA is R. So in total MO equals to 4 minus R. So here we found out that MO, the hypotenuse of the right triangle MNO, equals to 4 minus R, and we have already found out that NO equals to 2 times square root of 2R, and MN is the radius of the small circle. So here we implemented the Pythagoras theorem on the green right triangle, triangle MNO. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is MO, so the square of the hypotenuse is MO squared. So we focused on the right green triangle, triangle MNO, and according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MO square equals to MN square plus NO square. So here MO square equals to MN square plus NO square, and after we solved this equation, we found out that R equals to 1. So here in the right triangle, triangle MNO, according to the Pythagoras theorem, MO square equals to MN square plus NO square. According to the Pythagoras theorem, MO is 4 minus R, MN is R, so MN square is R square, and NO is 2 times square root of 2R, so NO square is 2 times square root of 2R squared. So MO is 4R squared, MN is R squared, and NO is 2 times square root of 2 times square root of 2R squared. So we open the brackets in this equation number 2, and we got that 4 minus R squared, it is actually 16 plus R squared minus 8R. And R, here we have R squared, and the square of 2 times square root of 2R squared, it is actually 8R. So here we have R squared in both sides of equation number 1, so R squared will get cancelled. And what is left after we cancelled R squared? Here, after it, we added 8R to this equation number 2. So here we have 8R minus 8R is 0, and here 8R plus 8R is 16R. So in total we got that we got that 16 equals to 16R. We divided equation number 2 by 16, this equation, and we got that R equals to 1. So R equals to 1 unit, the radius of the small circle equals to 1 unit, so R equals to 1, R equals to 1. And we know that CD equals to 2 minus R, and R equals to 1. So 2 minus R is 2 minus 1, 2 minus 1 is 1. So CD equals to 1, R equals to 1, and MC equals to 2 plus 1, that is to say it equals to 2 plus R, that is actually 2 plus 1, that is to say it equals to 3 units. Okay? And then we focused on those two right triangles, on the green right triangle and on the right triangle, triangle CDM, and we actually proved that those two right triangles can go into each other. That those two right triangles are similar to each other. Okay? Why they are similar to each other? First of all, we have those two angles. They are equal to each other, they are both right angles, so actually angle CY equals to angle CDM. They are both right angles, they are equal to 90 degrees. And we have this angle that is the common angle, it belongs to both triangles. This angle, angle C, belongs to the green triangle, and this angle, angle C, equals, it is also belongs to triangle CDM. So we can write down that angle C equals to angle C is a common angle that belongs to both triangles. And we also have those two angles that are equal to each other according to third angle theorem. So angle CY equals to angle CMD according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle can go to two angles in another triangle, then the first pair of angles must also congruent. And here we proved that those first pair of angles congruent, and this angle equals to itself. This is the second pair of angles that congruent. Therefore, the third pair of angles must also congruent. That is to say, angle CYE equals to angle CMD according to third angle theorem. I actually proved that the third angle theorem is true in the previous lecture. So we actually proved that all three angles in the green triangle CYE can point to all three angles in the right green triangle, triangle CMD. Therefore we proved that the green triangle is similar to triangle CMD according to angle similarity rule. We proved that triangle CYE is congruent, is similar is similar to triangle CDM according to angle similarity rule. And what is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle can point to all three angles in another triangle, then you proved that those two triangles similar to each other according to angle similarity rule. And from the fact that triangle CYE is congruent to triangle CDM, we will conclude that CE over CY in triangle CYE equals to CD over CM or MC in triangle CDM. I will repeat again. CE over CY in triangle CEY equals to CD over CM in triangle CDM. So CE over CY. What is CY? CY equals to 2 units. So CY is 2 and equals to CD. What is CD? We already found out that CD equals to 1 unit. CD equals to 1. And what is MC? MC is 2 plus R and R is 1. So MC is 2 plus 1. That equals to 3. So MC equals to 3. CD equals to 1 and MC equals to 3. So in total we found out that CE over 2 equals to 1 over 3. We multiplied the equation number 3 by 2 and we found out that CE equals to 2/3. So here we can write down that CE equals to 2/3. And what is the value of ED? ED equals to CD minus ED. ED equals to CD minus CE. ED equals to CD minus CE. So, and we already found out that CD equals to 1 and CE equals to 2/3. So in total we found out that ED equals to 1 minus 2/3, that is third. So we found out that ED equals to third, CE equals to 2/3 and CD equals to 1. Okay, and what is the value of OE? The value of OE actually equals to OD plus DE. Okay, OE equals to OD plus DE. But what is OD? OD is R and R equals to 1. So OD equals to 1 and we already found out that DE equals to third. So in total OE equals to 1 plus third. 1 plus third is 4 over 3. We found out that OE equals to 4 over 3 units. And then we actually connected points O and B. We joined points O and B by a straight line. And we calculated the size of angle OEB, the size of this angle. We found the value of this angle according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if you look on this side of the straight line XO, that is actually the diameter of the middle circle, and if you focus on point E, then the sum of the angles and this side of XO at point E must be equal to 180 degrees. That is to say, this angle is 90 degrees plus the size of angle OEB must be equal to 180 degrees. So around point E at one side of the diameter XO, the sum of the angles must be equal to 180 degrees. So one angle is 90 degrees plus the size of angle OEB must be equal to 180 degrees according to the rule that I stated. So here we will subtract 90 degrees from this equation, from this equality, and we will get that the size of angle OEB is 180 degrees minus 90 degrees is 90 degrees. So we found out that this angle is a right angle. So if angle OEB equals to 90 degrees, then triangle OEB is a right triangle. So I drew again the right triangle, triangle OEB. We know that OE equals to 4 over 3 units, and OB is the radius of the semicircle, therefore it equals to 4 units, and the only thing that is left to do is to find out the length of side EB. We'll find it according to the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to OE square plus EB square. We know that OB equals to 4 units, so OB square is 4 square. 4 square is 16, equals to OE square. OE equals to 4 over 3, so OE square equals to 4 over 3 square, plus EB square. So 16 equals to 4 over 3 square is 16 over 9, plus EB square. We subtracted 16 over 9 from this equation, equation number 4, and we got that 16 minus 16 over 9 equals to EB square. Here we multiplied 16 by 9 and then we divided it by 9 in order to have a common factor with 16 over 9. So in total we got that 16 times 9 minus 16 over 9 equals to EB square, and 16 times 9 minus 16 is 16 times 8. So in total we got that 16 times 8 over 9 equals to EB square. We know that 16 equals to 8 times 2, so we substituted 16 by 8 times 2, and we got in total that 2 times 8 times 8 over 9 equals to EB square. We took a root out of this equation, equation number 4, and we found out that EB equals to the square root of 2 times 8 over 9. The square root of 8 times 8 is 8, and the square root of 9 is 3. So in total we got that EB equals to 8 over 3 times square root of 2 units. Okay, we found out the value of EB. Then we actually proved that those green right triangles can go into each other. I copied again the 2 right triangles and we proved that those 2 right triangles can go into each other. Why they can go into each other? Because first of all, we know that OA equals to OB equals to 4 units. Those hypotenuses, they are the radiuses of the semicircle. Therefore, they are equal to each other. And OE is a common side, it belongs to both triangles. Therefore, OE equals to OE is a common side. So, by proving that those 2 sides can congruent in both triangles, we proved that those 2 triangles can go into each other according to rule number 4. What is rule number 4? Rule number 4 says that according to rule number 4, if the hypotenuse and the perpendicular in one right triangle can congruent to the hypotenuse and the perpendicular in another right triangle, then the right triangles can go into each other. And we actually proved that the hypotenuse OA and the perpendicular OE in the right triangle OEA can congruent to the hypotenuse OB and the perpendicular OE in the right triangle, triangle OBE. Therefore, we proved that those 2 right triangles can congruent to each other according to rule number 4. That is to say, triangle OEA can congruent to triangle OEB according to rule number 4. And from the fact that those 2 right triangles can congruent to each other, we will conclude that AE equals to EB. AE equals to EB, and they are equal to each other according to the rule that corresponding sides in congruent triangles are equal to each other. Those 2 right triangles can go into each other, therefore the 2 corresponding sides, that is to say AE and EB, will be equal to each other, that is to say AE equals to EB. And then what is AB? You can see from the drawing that AB equals to AE plus EB. Okay, AB equals to AE plus EB, but we know that AE equals to EB, so we can substitute AE in this equality by EB. So we substituted AE by EB in this equality, and we got that AB equals to EB plus EB. that is to say AB equals to 2 times EB. But we already found out that EB equals to 8 over 3 times square root of 2 units. Okay, so in total we got that AB equals 2 times 8 over 3 times square root of 2, or AB equals to 16 over 3 times square root of 2 units, or in terms of numbers, AB equals to 7.54 units. I will repeat again. The length of chord AB, it is actually 16 over 3 times square root of 2 units, or in terms of numbers, the length of chord AB is 7.54 units. Okay? Thank you very much.